Hi, my name is AJ Geis, and this is going to be my video explaining my final problem for CS50 Introduction to Python. The code that I chose to write is a battle simulator for the board game Axis and Allies. It's designed to simulate a land battle in the game and provide the user with a percentage based on whether or not they might win or lose if they were the attacking or defending platform. Now, without getting too much into the rule book of the game, which can get quite complicated, it basically boils down to this. You attack with a certain number of units. Each one of those units has an attack value associated with a six-sided die. So if a unit has an attack value of 3 and the user rolls a value of 3 or less, it's considered a hit. Each unit also has a defense value. Same rule applies if their defense value is 3. If you roll a dice and it's a 3 or less, that considers a hit. Normally, a value has a higher defense unit than it does an attack unit, but that's not always the case. Each unit also has an associated cost with it, meaning it costs a certain amount of in-game currency in order to buy more of those later on. And this code is designed to give you some predictions on the outcome of the battle and how much money you may or may not lose, or how much money you may remove from the opponent that you're actually trying to attack. So we'll go ahead and run the code here. Basically, it's going to ask you for how many attacking of each unit there are and how many defending of each unit there are. So we'll just plug in some values to see what it spits out. And now we're going to go to the defenders. The defenders have one extra unit the attackers don't have. That's the anti-air gun, which comes with its own specific rules that you can look up in the rule book if you would like. Let's give it some more. 3, and we'll say a bomber. Now it's going to spit out these tables. They're basically broken down into a couple different orders. The only difference between them is going to be how the defender and attacker are removing their units from the board game as the battle continues, and I'll break down what those are. But first, let's just kind of show what the results are. So this is being called the normal kill order, meaning that both the attacker and the defender are removing the lowest cost units first during the battle. And you can see the attackers win 41% of the time, defenders 57% of the time. And of note, these battles are being run 10,000 times, and that's where these are coming from. The next section is going to show you how many rounds of combat actually took place before a result occurred. And then it's going to show you the average loss of in-game currency for both the attackers and defenders. The next section down is going to show you that when the attackers did win, it's going to show you on average how many units did they still have remaining. So whenever the attackers won in this battle, on average they had 1 tank, 1 fighter, and 1 bomber remaining. And for the defenders, whenever they won, on average they had 1 tank, 2 fighters, and 1 bomber. And that's basically what this code is designed to do. The only difference with these next options you'll see is going to be how those units are removed. So I've also given to the user what I'm calling a max defense kill order, which is basically the defender is choosing to remove the worst defending units prior to the lowest cost units, meaning that they will sacrifice something that costs more in order to give themselves a higher probability to defend a territory. The next option after that is being called normal kill order and secure the territory. So this is the defender removing the lowest cost first, but the attacker now is going to remove the lowest cost first until they only have 1 land unit remaining, at which point they will start to remove those air units with the hopes of securing the territory at the end of the battle, because you need a land unit remaining in order to secure the territory, meaning they might have to remove some fighters or some bombers, which are much more expensive, but if their ultimate goal is to secure the territory, that's what will be necessary. And then the last option here is a combination of both of those. So what if the defender is going for max defense, and what if the attacker is actually going to secure the territory? And you can see how those percentages break down. All right, thank you very much.